talk about the quality of GIS data. Data in general are never perfect. We can't get precise data that is always exactly what we would like it to be. But what we're trying to do is find data of a quality that fits the purpose of what we're trying to do. So this means that a data set that might not be suitable for some sort of mapping might be suitable for others. For example, if we knew roughly the location of all the nuclear power plants in the world, we might not be able to make a precise map of where they are, an exact map, but we might be able to make a map showing which countries all of those occur in, and we could make ones that have more nuclear power plants a darker color, the country, than others, and we could map it in that way. But we do have a responsibility for making sure that the data we're including in our map is the best possible data that we could be using in order to suit the purposes of that mapping. So part of this has to do with geometric accuracy. In this example here, which road is correct? Well, looking at this figure, obviously, or perhaps the aerial photograph might look more correct because it's a photograph, but how do we know that photograph is in its exact geographic location? We really don't. And we would have to come up with some way to compare this data with something of known high accuracy. For example, if we walked with a GPS down this road and collected data points. And then we could see which of these two actually more closely represents where that road really is compared with where the GPS data was telling us. So just where something is part of the accuracy question. The other gets back to that attribute table. How accurate are those attributes we're putting into the table? For example, population or population density. Do we know exactly how many people live in Oregon or Washington or Idaho? We obviously have estimates of it from the US Census Bureau, which changes, of course, over time, but there's a limited accuracy to our ability to count the number of people within a state. And this would be the same for a bunch of things, tree crown density or anything else we might think about measuring in the field. We'd want to consider how it's measured, how accurate the measurements are, and what are the possible sources of error associated with those measurements. Resolution always comes into discussions of accuracy because the higher resolution the data you're collecting, typically the better the accuracy, although that's not always the case. So one of the types of resolution we talk about is spatial sampling resolution. So if we were collecting data with a GPS along the road, we could say that that the resolution of our data is known because we know that location within the limits of what the GPS is able to collect. So that's good for spatial data, but what about thematic data? For thematic data, other questions can come into play. For example, part of that might be how good the measuring scale was that was used to outline an area, but then maybe after that area is outlined, it's classified. So it's put into categories based on other data around it. So maybe for tree crown density, it's just a number between 5 and 10. So as it's reported on the map, we might not know precisely with accuracy how that was measured, but we know it falls somewhere in that category. And then, of course, the other thing that has to do with resolution is the temporal resolution, or the resolution with time. How frequently the data was sampled, and then that could vary from daily to monthly to every decade. And of course, that can have big effects on things like tree canopies that change with time, or even bigger issues like the location of rivers, depending on what, as they meander over time, or the location of a shoreline, which might depend on tidal variations. Precision has a couple of different meanings. We talked about if there's a line, how thick that line actually represents in the real world. But it's important to remember that precision is not the same as accuracy. Precision has two meanings. One of its meanings is basically the number of significant digits in a measurement. So if we're talking about a GPS and whether we can get within 3 centimeters of the location or 1 meter or 10 meters of the location, those would all be measurements of the GPS's precision. The other meaning of precision is the statistical variability of a repeated measurement. So if we measure a location with a GPS and then we go back an hour later and measure that same location, those 2 points might not show up on the same location in a map. And if we did that 20 different times, we would see that they kind of cluster in an area, but they're not all directly on top of each other. And we would be able to define with statistics what the standard deviation was as far as what where we were able to represent most of those measurements within a circle or an oval, and that would be another measurement of precision. So as far as the precision goes, measured in that way, a GPS's precision might be plus or minus 10 meters, something like that. Another important thing with considering this is the logical consistency. So sometimes we know in our mind that things should fit together or be coincident, but that's not always the case. For example, on the left here, we see West Virginia here and Virginia down here, and of course they share a state boundary. But if we zoomed in, would that line look the same? Well, it depends. If they use the same line, obviously it would. But if West Virginia and Virginia both map their boundary in two different ways, that line would probably cross over each other multiple times. So that's something to consider. If we want internal consistency, we have to use the same line as boundaries between polygons. And here's another example here. Maybe these two road segments actually do end like this. This could be a cul-de-sac, for example, that doesn't connect to this road here. Or maybe these two are supposed to connect, but the person digitizing it just didn't click right on top of that road in order to make this, this node associated with this line here on top of this line. And so we have to watch out for things like that. Whether these two lines were meant to connect or not is an important question. And sometimes we have boundaries based on other boundaries. For example, voting districts can sometimes be based on county lines. But if we overlaid the voting districts on top of the county lines, would those two sets of lines be perfectly consistent with each other? And in this case, they obviously are not. There are some differences there. And so if we were mapping with both of these, we would really want to consider which ones to use and how to deal with this data for purposes of internal consistency.